right, this is section 5-6, and now we're going to talk about multiplying the polynomials and special products. So that if they define it here to multiply monomials, we're going to use the associative and commutative properties of multiplication to group coefficients in like bases, and then we'll simplify the result by using the properties of exponents. So looking here at the first exercise, they want us to multiply the expressions. What you can do, what you're allowed to do by the commutative property is to rearrange. Some people find it helpful. For some people, they can see it without having to rearrange. Do you understand there's a 1 there in front of the b to the 4th? There's always an understood coefficient of 1 if you don't see one. So what you can do is put the coefficients together, the numbers, the constants, and then you can group the like bases together. In this case, we just have b. Now, remember, you're multiplying, so numbers get multiplied like always, but the properties of exponents they referred to up here told us that if I was multiplying and the bases were alike, that all I had to do was add up the exponents. Number 2, same story. You can group. I can put the 4 times the negative 1, and then I can put the bases of A together, and then I can put the bases of B together. Now, some people just do this more of a mentally. They know to put the 4 and the negative 1 together, and then they'll do the A's, and then finally they will do the B's. You need to do whatever helps you get to the correct answer. So 4 times negative 1 is negative 4. Multiplying tells me to add my exponents and get 6. And in this case, I get how many? 8. That is correct. Remember, there should be a understood 1 there. 1 plus 7 is 8. To multiply polynomials, we want to use the distributive property, which says I distribute A to the inside. Then, of course, you combine like terms. So we've already done this on previous assignments. This is not going to really be anything different. So for the first one, I'm going to distribute. Now, again, for some people, it is okay for them to just draw the arrows. For other people, it may be more helpful if you choose to write down the distribution. So plus 4xy times a negative 3x and plus 4xy times 6y. And so here now you see, here is that outside term being distributed to every term on the inside. So whichever way helps you, just don't shortchange yourself into not getting a correct answer. If it means a little extra work, well then by all means, please do that. So, and you could group these again. You could put the 4 and the 2 together. I think you should be okay just saying 4 times 2 is 8. x1 times x1, 1 plus 1 is 2. And then y1 and y1 makes y2. And then the same here, I'm going to say 4 times negative 3 is a negative 12. X and x, 1x and 1x makes x squared. And then you finally, you do have the y that didn't have any 1 to be paired up with or to be added to. And finally, 4 times 6 is 24. And you bring down the x and you have y and y, which makes y squared. Number 4. Now, most of the time, you really don't see this on the end, this monomial times a trinomial. They will usually have your monomial out front. And I have found a lot of students, they prefer to do a rewrite like this, just to put it out front. And they see it better. They understand then better what they're supposed to be doing. And that is, of course, distributing. Now, whether you just simply distribute or you like to come over here and rewrite it, showing that outside term, monomial, being multiplied times each term on the inside, either way is fine. You're going to get a positive 15j to the third, a negative 20j squared, and a positive 10j. If you don't see it doing it that way, come over here and work it out where they are grouped side by side. Either way, you're going to still come up with the same answer. Okay, let's talk about 5 and 6. 5 and 6 is a binomial times a binomial. And in most high school settings, you were taught a saying to help you remember how to distribute this, because all you're going to do is distribute. And a lot of them taught you to say you FOIL. And a lot of students will even ask, am I supposed to FOIL this? And what that stood for was the first, get my pen to working, here we are, first, outer, inner, and last. And this was really just giving you a direction as to how you actually distributed. But what you're really doing is saying, okay, I'm going to say B times everybody in the second group. So you're going to say B times everybody in the second group. Plus, then you're going to take the -4 and you're going to distribute it to everybody in the next group. So I'll say -4 times B plus 6. And so that ends up being B squared plus 6B. And then right here, this gives me minus 4B minus 24. And that gives you B squared. These are your like terms. 6 minus 4 is 2 minus 24. Now, if you are a person that was taught to FOIL, then what you'll want to remember, let's just go through that real quick. The first terms. These are your first terms. Then it said do the outer terms. These are the outer terms. And see, look, you distributed B to each one by saying do the first and the outer. And then the next is the inner terms. Well, this is your innards. And that would give you -4B. See, that's the first distributing of -4. And then finally, you got -4 times 6, which is your last terms, which makes -24. Well, look at there. You still have the same answer. So no matter if you try to think FOIL or you just think distribute, they're really the same thing. Again, whichever method you are most comfortable with. Number 6. So I'm going to take the 4P and I'm going to distribute to everybody in the second group. And then I'm going to take the -3 and distribute it to everybody in the second group. I'm going to do 2 distributions. Or you can do FOIL. Think FOIL and work it out that way. So let's pause the video. I'm going to work it out. You work it out and let's see what we end up with. Okay, so here's what I ended up with. Compare and see where you messed up, maybe what you need to go back and look at. Number 7, again, this is a binomial times a binomial, which tells me you can either do the FOIL method that many of you were taught in high school. Basically, it is just you distributing. You're going to take 5, and I'm going to distribute it to everybody over here on the right side. So if we wrote that down, it would be 5A times 2A plus 5A times 3B. And then before I get started on that, I want to go ahead and write down what else I'm going to distribute. I'm going to say negative, let's close those parentheses, my mistake. So -4B times 2A and -4B times 3B. All right. And so when you multiply, you get 10A squared plus 15AB minus 8AB minus 12B squared. Now let's talk about what I did for just a minute. If you need to, pause and look at where my numbers come from. But what I want you to also see is notice that when I multiplied these together, notice I put them in alphabetical order. I put the A in front of the B. Over here I did the same thing. A in front of the B. You want to have some consistency in this so that when you go to look for like terms, it makes it a little easier to compare. Because remember, they're not like terms if they don't have matching exponents, matching letters and matching exponents. So now when I look at this, I can easily see, hey, look at these two. They're both AB to the first power. Now, multiplication is commutative. So if you have A times B or B times A, these are exactly the same thing. They both have a base of A and B and both to the first power. So, but it makes it a lot easier if you will put it alphabetical order for you to easily recognize, hey, these are like terms. So 15 minus 8 leaves you with 7AB minus 12B squared. Now, again, these, just because they got a square on them, doesn't mean they're like terms. They're two different letters, so they are not like terms. This would be my final answer. Number 8 is actually a binomial times a trinomial. So to do this one, you were not taught any cute little saying or method to do this. We're just simply going to distribute. I do want to caution you to make sure you keep everything organized to make sure you don't lose a number or a sign. So I'm going to first distribute 2a times 4a squared plus 6a plus 9. And then I'm going to distribute the negative 3 times everybody. So like I said, sometimes it helps if you will break it down. So I broke it down into two parts first, and then if you need to rewrite it even further, you can. You might be able to look at it now and do your multiplication. 2 times 4 is 8, and a, remember this is to the first power, with a squared, these are being multiplied, so I will add them and get a to the third. And then finally I'll do 2 to the 6th. So that makes 12a squared plus 18a. All right, let's do the negative 3 now. That makes a negative 12a squared, a negative 18a, and a negative 27. Now they all belong together. It's not like two different problems. This is one whole problem. So let's go looking for some like terms. I have no more cubes. I do have an a squared and an a squared. I have an a and an a, and that's it. So let's put those together. All right, I have an 8a cubed. These zero out, as well as the 18a and the minus 18a. So all I'm left with is 27a cubed, 8a cubed minus 27. Number 9. Okay, this one, I do not care for this being used in this fashion because it's easy to get, to lose a number, to forget to distribute a sign, to watch your signs. We reserve this stacking in this vertical direction for adding and subtraction. I'm going to strongly suggest that you rewrite this horizontally if you're going to multiply. Or what you're going to have to do is look at it and understand. You're going to say 2x times everything in that trinomial, and you're going to say then negative 1 times everything in that trinomial. But typically we reserve this stacking for adding and subtracting, not for multiplication. And a lot of times we steer away from using this x here to represent multiplication because in algebra that we do, it's so many times represents the variable, especially in graphing. So rewrite it, and now we're going to complete it just like we have before. We're going to distribute 2x to everybody first. And that's going to give me 10x to the third minus 6x squared plus 8x. And then this would be negative 1, 5, that looks like 15, excuse me. Negative 1 times 5 is negative 5x squared, and a positive 3x and a negative 4. All right, so your next step always is can you simplify? And you simplify by combining like terms. I don't have another cube in this problem, but I do have a square and a square, and I do have a linear and a linear. All right, so I'm just going to combine my like terms. 10 gets brought down. Negative 6 and negative 5 is negative 11x squared, Plus 8 plus 3 is plus 11x minus 4. Now we're going to look at some special case products. One of them is the difference of squares, and the other is perfect square trinomials. The sum and difference of the same two terms is called conjugates. So if you've got, notice here, same numbers, different signs. 2x, 2x, 7 and 7, but the signs are different. Look at the one below it, 4 plus 5x, 4 minus 5x. Those are called conjugates. And what happens is when you multiply them together, your answer is the difference, remember that subtraction, between the square of the first and the square of the second. What basically happens is we like to say the middle stuff, your middle terms, your linear terms, add to be 0. A lot of students say, so the middle stuff falls out. Well, yeah, that's basically what happens. Your middle stuff, your middle terms, add to be 0. And we call this the difference of squares. Now, you need to really get a handle and understand this is what's happening, because we're going to turn around and factor it in upcoming sections. And we'll say to do the difference of squares, and you need to understand that means one's added and one's subtracted. Same terms, different signs. So let's look at this more on the next page. So I'm going to take you through these first couple ones step by step and let you see how the middle terms will add to be 0. So we're going to, this is a binomial times a binomial. Some of you would like to fold this. I just simply like to say we're going to distribute. I'm going to distribute 3x times everybody on the right side. If you need to write that down so that you can see it, that's fine. And then I'm going to distribute the next term, 5y, to everybody on the right side, to the second binomial. And so what happens here is I get 9x squared minus 15xy plus 15. All right, now right here, when I multiply these two together, I'm going to put them in alphabetical order. So I'm going to say 15xy, and then I'll distribute this, and that's a negative 25y squared. So look what happens right here. Look what happens to your middle terms. Negative 15 plus 15 makes what? 0. Those are like terms. They zero out. The middle terms fall out. And notice, so let me rewrite this because I have it all covered up with my arrows. Remember the problem said 3x plus 5y and 3x minus 5y? Take just 3x, the first term, and square it. What do you get? 9x squared. Take the last term and square it. What do you get? 25y squared. And what is a positive and a negative multiplied? Signs are different, so it's subtraction. Isn't that what you got right here? If you flip back to the other page and look at the definition, you will see that this fits the definition. It's the square of the first minus the square of the last. It's the difference in the square of the first and the last. All right, let's look at that same thing on number 11. I'm going to do it two ways. I'm going to talk about two different ways and help you get a mental understanding. The numbers are the same, 5, 7a, 5, 7a, but your signs here are different. They're called conjugates. That's the word we call them. So you can rewrite it 5 times 5 plus 7a plus negative 7a times 5 plus 7a. And you're going to get 25 plus 35a minus 35a minus 49a squared. What happens here with your middle terms? Positive and negative make a 0. You're left with the first 25 and the last 49a squared. Let's rewrite it and just look at it. If you had noticed these were conjugates and you just squared the first and you just squared the last and you made it the difference because that's what a negative and a positive are. It's a negative. Do you have the same answer? Yes, you do. Moving on, let's look at 12. Are they conjugates? Yeah, they are. Same numbers, different signs. So before I even distribute it out, I'm going to say it's going to be square the first, make it the subtraction, the difference, and then I'm going to square 2/3. Did you know what that is squared? 4/9. Now, why did I not put a decimal? Well, for one reason is they gave me fractions in the problem. And for another reason, I wanted an exact answer. I don't want to have to round it, truncate it. I want it to be exact. So let's work it the long way just to prove to you. R, the first term, times everybody in the second set. So that's R minus 2/3 plus, and then I'm going to have 2/3 times everybody. So what's that going to give you? R squared minus 2/3 R plus 2/3 R minus 4/9 when you distribute this. Your middle terms add to be 0. And you can see there, we did end up with the same thing. Finally, 13. Okay, what I want you to do is pause and just think about what we've talked about in the last 3 questions, last 3 problems. Can you go straight to your answer? What do you think your answer would be, just understanding these are conjugates? So it's actually the difference of 2 squares. So what would that look like? What do you think that answer would be? Did you get this? No? Well, let's look at it. It's going to be the first term, 2, times everybody over here. So that's 2 times 2 plus 5x squared. And then it's going to be the second term times everybody. So that's going to be negative 5x squared times 2 plus 5x squared. So that's 4 plus 10x squared minus 10x squared. What is, and this is what gets people, what are these two? That's a negative 5x squared times 5x squared. 5 times 5 is negative 25, but when you're multiplying, base times base are the same. What do you do with your exponents? You add them. A lot of people tend to forget to add those together. There's that middle terms zeroing out, and you just have 4 minus 25x to the 4th. Our second special case is squaring a binomial. For example, if you have 2x minus 5 squared, or if you have 4x plus 7y squared. When squaring a binomial, the product will be a trinomial called a perfect square trinomial. Now, the first and third terms are formed by squaring each term in the binomial. The middle term equals twice the product of terms in the binomial. So I want to show you a couple things here. There's one for addition, and there's one if you subtract it. Let's just look at a couple examples. First off, I want to show you what a common mistake people make. People assume that they can jump right to this and say, my answer is c squared plus 25, and this is wrong. You don't square the first and square the last. You have to remember that this means c minus 5 times c minus 5. There's 2 terms here, which therefore would mean you're supposed to distribute and get c squared minus 5c, and then distribute the negative 5 again. So you end up with, like the definition said up there, a trinomial, not a binomial that so many people think you do get. Now, there is, when it is written as a binomial squared, there is a shortcut or a saying that can help you more quickly evaluate this. And I have used it many times, and it square, double, square. And I say square, double, square. Now that comes from this definition right here where they told you right over here. The first and the last, the first and the third are by squaring. So I'm going to square the first, square the last, and then I'm going to twice, which is the same word as double, the product. So I square the first, I double the product, and I square the last. Here they broke it up in the way I say it, I put it in order. What you do first, what you do second, and what you do last. So watch how this works out. If I'm going to square double square, what you simply do is I don't have to rewrite it. I'm simply going to take the first term and square it. That's c squared. I will multiply these two together. Basically, you're going to combine them. Negative 5 and a c. That amount doubled is negative 10, right? Negative 5 and negative 5 is negative 10. Usually when you combine these terms in the middle, it is a simple number that you can double in your head, that you can multiply by 2 easily. And then finally, I square the last. Negative 5 squared is a positive 25. And see, here I am at the answer, and I am basically eliminated these 2 steps in the middle. Now, is it wrong for you to write it out and expand it? By no means. But there are some things that we try to learn some little quicker ways to compute, like your multiplication facts for one, to keep our brain from being so tired, to get through these problems a little quicker. All right, let's look at 15. So you can expand this. You could write 5d plus 9 times 5d plus 9, and then go through the distributing properties. I'm going to come right here, and I'm going to take you through my little shortcut, square, double. We'll put DBL for square for double, and we're going to say square. So I'm looking at 5d plus 9 squared. If I square the first, I get 25d squared. If I combine these two, that's 45d. You may need a calculator for that. 45 plus 45 is 90d. And then I square the last, I get 81. Now, if you didn't want to do that, you did the long way, you would have 25d squared plus 45d plus 45d plus 81. Well, that's everything we just did over here to the right. We just combined them and wrote them down as we were going. 16. All right, so let's just go straight to the little shortcut. Square, double, square. I know to do this because it's a binomial squared. That allows me to do square, double, square. So if I squared 3, I'm going to write it over here. If I square 3, I get 9. If I combine these, that's negative 15g. Doubled makes 30. And then if I square the last, that's a positive 25g squared. So, don't believe me? I want to write it out the long way. You're going to still get the same thing. So that's 9 minus 30g plus 25g squared. Okay, so we're going to look at 17 part A, B, and C. What they're finally getting down here on part 17, they want us to say what is the difference in it having the parentheses or just squaring each number. And this is going to take us to the what I told you was the most common mistake back on the page before. And we'll talk about that again, about why these are not the same thing. So number 17, part A says they want us to evaluate the parentheses first. So 5 minus 3 is 2, and 2 squared is 4. And then they went ahead and give each number a square. This is 25 minus 9. Well, 25 minus 9 is 16. Notice these are not the same two things. So if you have a minus b squared versus a squared minus b squared, these are not going to be equal. You've used a number to prove that. This first one is a squared minus 2ab plus b squared. It is not going to be equal to a squared minus b squared. So if you're given a problem such as x minus 4 squared, you cannot say, oh, that's x squared plus negative 4 squared. These are not going to be the same thing. This is actually x squared minus 8x plus 16. See here, you left out a middle term when you don't properly work it out.